Okay, so today we're going to be talking about arithmetic sequences. Arithmetic sequences. So all this is a sequence, and a sequence just looks like this. So this is a sequence, this is a sequence, all of these are sequences, okay? So a sequence made by adding or subtracting the same value each time. So that's a key word. You have to be adding or subtracting the same value each time. A common difference is the difference which is labeled D in our formula. So make sure you know that the common difference is labeled D in our formula, which we're going to get to in a little bit, between two numbers in an arithmetic sequence. So the difference between two numbers in an arithmetic sequence. So we're just going to practice first. You can pause the video if you need to finish writing down those definitions. And then we're going to be identifying an arithmetic sequence. So all we're going to be doing is seeing, oh, okay, is this sequence arithmetic or not? So let's do that first. So we're just going to see if it's arithmetic or not. So is this arithmetic? Well, if we look here, we're going from this to this to this to this, right? So from 1 to 5, what are we doing? Are we adding? And remember, arithmetic sequence is made by either adding or subtracting. So are we either adding or subtracting the same number from 1 to 5? So let's see, what is 1? How do we get from 1 to 5? What do we do? We're going to add 4 there, right? And then 5 to 9, add 4. And then 9 to 13, add 4. So is this an arithmetic sequence? Yes, it is, because we're adding the same number. Okay, and then it says if yes, identify the common difference. So remember my common difference up here, my common difference is D. So I'm going to say, yeah, it is an arithmetic sequence. D equals 4. So D is whatever this number is that we're adding or subtracting. Okay, let's go on to number 2. So here from 1 to 3, here, we're adding 2. Adding 2, but then here we're adding 3. Do you see from 5 to 8 we're adding 3? So are we adding the same number each time? No, so it's not an arithmetic sequence. Okay, so here from 8 to 6, we're subtracting 2. 6 to 4, subtracting 2. 4 to 2, we're subtracting 2. Is this an arithmetic sequence? Yes. This time D equals a negative number because we're subtracting. Okay, next one. So on this next one, negative 5 to negative 8. Okay, so we're getting lower in our negatives, right? We're going from negative 5 and we're going down to negative 8, down even farther to negative 11. So we're subtracting 3 here. From negative 8 to negative 11, subtracting 3. Negative 11 to negative 14, subtracting 3. So it is arithmetic. And D equals negative 3. Be careful with the negatives there. Okay, next one. 5 to 10, adding 5. Are we adding 5 from 10 to 20? Nope. So that's not an arithmetic sequence. And then here, we're subtracting 1, subtracting 1, subtracting 1. So yes, D equals negative 1. We're subtracting 1 each time. Okay, the next thing we're going to do is continuing arithmetic sequences. We're going to given the arithmetic sequence, find the next 3 terms. So it's telling us it's arithmetic. We just have to find the next 3 terms. So let's look here. Let's find out what we're doing here. So 9 to 13, adding 4, adding 4, adding 4. Okay, so add 4 to 21. Plus 4, we're going to get 25. If we add 4 to 25, we're going to get 29. If we add 4 to 29, we're going to get 33. Okay, next one. Let's look here. If we're subtracting now 3 to get to 2, subtracting 3, subtracting 3. Okay, so what's negative 4 minus 3? It's going to be a bigger negative number, so we're adding those two and making it negative, keeping the sign. So negative 7. subtracting 3, we're going to get negative 10. Subtracting 3, negative 13. Okay, last one for this. Here to get from negative 8 to negative 2, we're getting higher. We're actually adding this time. We're adding 6. So from negative 8 to negative 2, the negative is getting smaller, so we're going to add 6. Add 6. 4 to 10, we add 6. Okay, so obviously our D, our common difference here is 6, positive 6. We're just adding 6 all the way down. 22, add 6, and 28. Oops. Okay, so arithmetic sequence formula. So we just figured that out, but what if I asked you, okay, see how it says find the next 3 terms? What if I told you find the 100th term for like number 7? So this, let's just say this was the first term, because it is, right, in this sequence. What if I said find the 100th term? So you're like, okay, 1, 2, 3, 4, 5. This is going to take forever. You don't want to add 4 all the way down. So that's why we have a formula that we're going to be using to find something called the nth term. You know how I said up here, find the 100th term for number 7? That would be here. Instead of n then, it would be 100th. So I said, if I said find the 100th term, that's all the nth means. That just means whatever number I ask you to find. So find the 100th term, find the 10th term, find the 1000th term, I don't know, of an arithmetic sequence. That's all that nth means, okay? And it can be found using this formula. Okay, so don't let this formula freak you out. It might look a little different, but it's, once we do a few, you guys, this is really simple. It's not that hard. We're just plugging in numbers here, and we're going to be doing the same thing all the way down, so you'll get the hang of it. So this just says A sub n equals D. Remember our D, our common difference, like here, the common difference would be positive 6, right? So we just plug in a 6 here if we were using this one, times n minus 1, okay, plus A sub 1. Now this A sub 1, so let's actually write down what D equals. We know that D is down here is the common difference. We did that. We've been doing that the whole time. Every single time we either added or subtracted above, that was our D, right? That was our common difference. Now we have this new term though that says A sub 1. So this A sub 1, that's the first term. You see this 1 down here, this little guy right there? That means that that's whatever term you're trying to find. So this 1 means first term. So A sub 1 is the first term. If it was A sub 2, oops, I'm spelling term wrong. Okay, term. If it looked like this, that would be second term. If it looked like this, that'd be the 100th term. So whatever this number is down there, that's the term that they're talking about, okay? So this just means always, that's always in your formula, that just means the first term, okay? So let's practice a little bit so you can kind of see how this formula works. So it says write the rule for the nth term. So we're writing a rule first and then finding A sub 19. So remember how I said that this 1 right here means the first term? This means find the 19th term. Okay, that just means find the 19th term. So let's write a rule first. So I'm going to write out the formula first just because it's new to us. You don't have to do this every time, but I'm just going to show you where we're plugging into so it kind of makes sense. So all I did here was write this formula out right here. This formula, I just copied it. So it says write the rule for the nth term. So let's figure out what our common difference is because we've been doing that the whole time. So let's find out what our common difference is. From 7 to 13, what do? We're going to add 6, right? Add 6 from 13 to 19. Add 6 from 19 to 25. So our D is positive 6. It's just a 6, right? Now, this new thing we just talked about, A sub 1, up here, A sub 1, which we need that guy too, right? So A sub 1 is just our first term. What is the first term in this sequence? Well, it's 7, right? Whatever the first term is, literally whatever it starts with, that's your A sub 1. So it's 7. Okay, now we can make a formula. That's all we need. That's all we need. So let's plug in now. let's plug in to a sub n. I'm going to keep this the same. A sub n equals d is 6. Now I'm going to keep this n minus 1 the same. We didn't write n over there, but we do have an a sub 1, right? So our a sub 1 here is 7. So I'm going to plug in a 7 right there. So all I did was substitute in 6 for d and 7 for a sub 1. You guys, make sure you're organized when you are plugging things in, okay? Make sure you're organized. Just carry it down. Write the formula out first, plug in what you know, which is this, and then keep going. So what can I do now? Well, I can distribute, right? This is distributive, so let's do that. Let's keep a sub n the same. Equals 6 times n is 6n. 6 times negative 1 is negative 6 plus 7. Do I have anything on the same side of the equal sign that I can collect? Yeah, I can collect this right here. I can collect this. So it's negative 6 plus 7, positive 1. This is my formula. This is my formula. This tells me whatever number I plug in for n here, I'm going to plug in for n over here to find that term. So if I say here, find a sub 19, that means I'm going to find the 19th term. All this means, if you want to write that, that just means find the 19th term. The 19th term. Cool. So let's find the 19th term. So we're just going to plug in wherever we see n, we're going to plug in 19. A19 equals 6 times 19 plus 1, right? Because all we're doing here is substituting in 19 for n. We're substituting in 19 for n. We kept the 6 and the 1 the same. So now let's just solve. A sub 19, our 19th term, 6 times 19 is 114 plus 1. That means our 19th term is 115. That's what that means. That's all that means. So our 19th term is 115. Cool. Okay. Not too bad, I don't think. So now we're going to do the same thing. We're going to see, okay, how do we get from 30 to 26? Minus 4. So what is our minus 4? Minus 4. What's our d? Well, negative 4, right? D is negative 4, whatever we're doing to get from one term to the next. Okay, what about our first term? Our first term is this, 30. Cool. So now let's write our formula out. So a sub n equals d times n minus 1 plus a sub 1. So let's plug in what we know. We're going to keep a sub n the same. We're going to plug in our d. Our d here is negative 4. We're not going to change n minus 1. But we also have an a sub 1, which is 30. Great. So now we're just going to distribute again. So a sub n equals negative 4n. Now negative 4 times a negative 1. Be careful, you guys. It's positive 4. Little mistakes like that can really get you on the test. Okay, so now we're almost finished. A sub n equals, notice the pattern, we can collect these two last terms, negative 4n plus 34. Great, we have our formula. That's it. That's all. Now we need to find the 19th term, because that's what it says, then find a sub 19. So plug in, I kind of do like a dashed line here to separate. So now we're going to find the 19th term. So I'm going to plug in a 19 equals, let me do a different color. Okay, a sub 19 equals negative 4 times 19 plus 34. So a sub 19, if you use your calculators, negative 4 times 19, I have to do it too, so I'm doing it on the side really quick. 4 times 19, 76, so negative 76 plus 34. So that means our 19th term here is negative 42. You just combine like terms. So negative 76 plus 34 is negative 42. Okay, so let's take a look at number 12. So here, what are we doing from negative 11 to negative 8. We're adding 3. We're adding 3. We're adding 3, right? If you're not sure, use your calculator. So negative 11, if you're like, I don't know how to get to 8, try it. Do negative 11, and then maybe if you thought, oh, I'm subtracting 3, then you're like, oh no, that's getting bigger, right? So negative 11, okay, let's try adding 3. Okay, that's negative 8. So don't be afraid to use your calculator to figure this out. Okay, so D is positive 3. Just went through that. I'm not going to write a positive there. That looks confusing. D is 3. Okay, A sub 1 is just our first term. What's our first term here? Negative 11, right? That's the first term in the sequence. Great. So now let's plug it in to our formula. So I'm not going to write the whole formula out again. A sub n equals, but I know it's D, right? D times, so I'm going to write 3 times n minus 1. Now, minus 11, because that's our A sub 1 now is a negative, right? A sub 1 is a negative 11. So A sub n equals, now I'm going to distribute, 3n minus 3 minus 11. I can collect these two like terms. So remember when we're adding two negatives, or when you have two negatives, like negative 3 minus 11, we're adding them and keeping the sign. If you're not sure, again, use your calculator. That's why I give it to you guys. Okay, I'm going to do it over here. I'm going to find A sub 19. Remember on our last page it said find A sub 19. So A sub 19 equals 3 times 19. You're plugging this always in for n, minus 14. So A sub 19 equals, okay, and when you figure that out, that's going to be 43. So do 3 times 19 first, minus 14. And that's going to be 43. Let's skip down to 14. Let's skip down to 14. Okay, so here, to go from negative 16 to negative 21, we're subtracting 5. Again, use your calculator if you're not sure. Okay, so if you're not sure, use your calculator. Guess and check. Negative 16 minus 21. Negative 16. If you're like, okay, how do I get to a negative 21? Even if you're just like, I don't know, subtract 3. We're closer, right? So negative 16, subtract 4. We're closer, right? So keep doing that. See the pattern too once you do it. Like, oh, okay, I'm getting a greater negative. That's why I'm subtracting 5 here. Okay, so subtracting 5 all the way across. We just want to check to make sure our common difference is the same all the way down, and it is. It's negative 5. And then we have our first term, A sub 1, which is negative 16. This is always our first term. Now we plug it into our formula. A sub n equals D times n minus 1 plus A sub 1. So A sub n equals, our difference here is negative 5 times n minus 1 plus, okay, if it's a negative here, please do not write plus negative 16. That looks really confusing, and I think that confuses a lot of you. If it's a negative here, just write minus 16, okay? So instead of writing plus negative, just write a negative 16, okay? Because we're substituting this negative 16 in for A sub 1, so it's going to be negative. Just write it negative, okay? Let's distribute here. A sub n equals negative 5n plus 5 minus 16. A sub n equals, now we can collect these two like terms, negative 5n. So positive 5 minus 16 is a negative 11. Great, we have our formula. Okay, let's plug it in. So I'm going to do it over here again. A sub 19 equals, actually, I'm going to rewrite it up here. A sub n equals negative 5, and because we have a lot of negatives, minus 11. We're finding the 19th term, so we're plugging in 19 for n. We could find any term. We could find the 100th term. We could find the millionth term. Okay, so it just depends on what they ask us for. Okay, so 19 times 5 here is negative 5 is negative 95 minus 11. So So a sub 19 equals negative 106. So the 19 term is negative 106. Okay, don't worry about 15. Let's talk about 16. So you visit the Grand Canyon. This would be pretty cool to do with your friends. You visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second, 48 feet the next second, 80 feet the third second, and so on. So what does this look like? Well, 16 feet the first second, 48 feet the the next second, and 80 feet the third second, and so on. So I'm going to put dots there to show the so on. Okay, it keeps going, keeps falling, right? Write a formula to represent this sequence. Okay, well, we know what to do because we're trying to get into this, right? A sub n equals d times n minus 1 plus a sub 1. So what pieces do we need? We need d and we need a sub 1. So I'm going to write out a sub or d equals and a sub 1 equals. How do we figure out our common difference? Well, we do this, right? We're going to subtract here. We're going to add to get from 16 to 48. We're going to add 32. From 48 to 80, we add 32. So our d is adding 32, positive 32. What's our first term? Our first term here is 16. So a sub 1 equals 16. Great, let's plug it in. A sub n equals, we have our d, n minus 1, we have our a sub 1, and now we're just going to distribute. A sub n equals 32n minus 32 plus 16. We can combine like terms here. So a sub n equals 32n minus 16. That's our formula. Okay, so now the next question says, how far will the penny have traveled after 6 seconds? So we're going to plug in 6. 6 is our n. So this is just saying n equals 6. So we're going to say, okay, a sub 6 equals 32 times 6 minus 16. We're just plugging it into that formula, right? Okay, so 32 times 6 is 192 minus 16. So 182 minus 16 is 176. So how far, don't forget to label, how far will the penny have traveled after 6 seconds? 176 feet. It will have traveled 176 feet after 6 seconds. All right. The total bank loan for Sarah's new car. Now this right here, this is a challenge question. It's challenging, okay? So make sure, like something like this could be extra credit on your test. So let's look at it. The total bank loan for Sarah's new car is $15,265 and this is like a real life kind of a question, right? The bank automatically withdraws $295.80 each month to pay off the car. So maybe something smaller that you can think about right now, like your cell phone bill. I don't know if you pay for it yet or if you have to pay for it soon, but that's something like, okay, you have a certain amount in your savings account maybe, and then you take out a certain amount, maybe $50 each month to pay off your phone bill, right? So that's, and eventually you will withdraw money for other things, and usually it's the same amount each month. So here it's $295.80, right? So it says write a formula to represent this sequence. So this is more difficult. Like up here it gave us the sequence, right? It said okay, 16 and then 48 and then 80, but here it doesn't tell us that. So we just have to think, okay, the total bank loan for her new car, for Sarah's new car, is this much, right? $15,265. Remember a sub 1, how we have to find that first? A sub 1 is the first month. So it says write a formula to represent this sequence, and it withdraws this much money each month. The first month, the very first month, she's not going to have this much on her loan. she's going to have 15,265 minus, because withdraws means take out. So this withdraws means take out, right? It automatically takes out $295 each month to pay off the car. So we're going to have to take $295.80 away from $15,265. So let's do that first. So I have $15,265, and I'm going to subtract. Why subtract? Because it says withdraw. Withdraw means take out. It means take away, right? So the first month is $14,969.20. So remember, A sub 1 always means the first. So like the first month of this, she's going to have $14,969.20 left on her loan to pay. She still has this much money to pay. What's my common difference? It's this guy, $295.80, because it withdraws each month. Each month it takes out this much. So the common difference is negative $295.80. Why negative? Because withdraw means negative. It means take out, right? We just subtracted our total from $295.80 to get this number, $14,969.20. Okay, so let's plug it in. A sub n equals, now our D is negative $295.80 times n minus 1 plus our A sub 1, which is $14,969.20. That's how much she has left after the first month of paying off her car loan. She still has that much left. So $295.80, we're distributing now, n. Now negative $295.80 times negative 1 is a positive $295.80 plus $14,969.20. Okay, so we can combine like terms here. We can combine these two, right? So negative $295.80 n plus 15,265. That is my formula. This is A sub n. And this makes sense, doesn't it? Because think about this. This is how much she has to pay on her loan, right? And every month we're subtracting $295.80. So let's say after 1 month, you plug in a 1 here, right? For 1 month, you would plug in a 1. Didn't we just do 15,265? Well, anything times 1 is the number, right? So what's 15,265 minus $295.80? Didn't we just figure out the first month here, she's going to have to pay this much? Yeah. What about the second month? Well, we'd plug a 2 into here, and we'd say 15,265 minus whatever this number is times 2. And that's the second month. And then we'd have something called A sub 2, which is the second month, right? So, and so on and so forth until she finishes paying off the car. So now it says, what will the balance of the loan be after 2 years? Now here's the trick. We can't plug 2 into there. Didn't we just say for 2 months we'd plug 2 into there? 1 month, didn't we plug 1 into there? How much after 2 years? How many months is 2 years? Well, to figure that out, we do how many months in a year? 12 months in a year, right? So 12 months in 2 years, for 2 years, that means 24 months. So now we're going to plug that 24 back into our n. We're going to plug that back into here. It says after 24 months, what will the balance be? Which is the same thing as saying what will the balance be after 2 years, right? So I'm going to do this. I'm going to write A of 24 because that's how we write it, right? After 24 months, and then I'm going to plug in 24 into my equation. 24 plus 15,265. All right, I'm going to do that in my calculator here. So I have negative 295.80 times 24. So negative 7,099. I think it was 0.20, right? Yeah, 0.2. Plus 15,265. And then if I combine those, So I'm going to add $15,265 to that. $8,165.80. So that means after 2 years, she'll still have this much money to pay. What's the balance of the loan? Well, $8,165.80 after 2 years.